Okay, we're going to do a brief review. We've been dealing with expressions with exponents in it. I'm going to do a little bit of vocab real quickly. If I have x to the third power, this x is called your base. That's the thing that's being multiplied by itself. The 3 is called your exponent. That's the number of times that you multiply something. So this is the same as x times x times x, x being your base. The exponent tells me how many times to multiply by itself. One of the things that I've seen confusion about, if I have something like this, which is 2x to the third power, in this case 2x is your base and 3 is your exponent. This is the same as 2x times 2x times 2x. Versus if I have something like this, 2 is a base, but it's got an exponent of 1. And x is a base, but it's got an exponent of 3. And if I were to expand this, it becomes 2 times x times x times x. Okay? Just a brief reminder of that. We have been learning some exponent rules. You actually never need to know any of these rules if you know how to expand. But the first rule that we found is if you have two exponents that have the same base and they're being multiplied, you can add those bases together. This would be the same as x to the a power times x to the b power, because they have the same bases, would be x to the a plus b power. And I can prove this if I did x squared times x to the third power. That's the same as x times x times x times x times x, which is equal to x to the fifth, otherwise known as x to the 2 plus 3, which is equal to x to the fifth power. Okay, that we learned last week. The next rule that we learned was that if I'm dividing x to the a power divided by x to the b power, that comes out to be x to the a minus b. And again, I can prove this. It works every time, whether you're using numbers or letters. Say I have x to the third power divided by x squared. That's x times x times x, all over x times x. These cross off, and this is equal to x. And x to the 3 minus 2 power is the same as x to the first power, which those are the same. Okay? So that was our second rule. Today we're going to learn our third rule. And the third rule is that x to the a power to the b power is the same as x to the a times b. And I can prove this again by doing an example. If I took x squared to the third power, that's the same as x squared, and I need 3 groups of these. And if I expand that even more, x squared is x times x, x times x, and x times x. This then becomes, if I count all those, that's x to the 6th power. And if I take 2 times 3, well, 2 times 3 is equal to x to the 6th power. Okay, so that's our third rule. And that's something that you're going to practice today. Again, be aware of what your bases are. I'm going to show you one last rule, and I'm going to add it to this board at the end, but I want to show you a pattern. It's best to show it that way. So if I started out, we're going to use that division rule. So if I have 2 to the third power, and I'm going to do this with numbers, and I'm dividing it by 2 to the first power. Well, we learned that when I'm dividing and it has the same base, I can just subtract those. So 2 to the 3 minus 1 power is the same as 2 squared, which we know that's 2 times 2, which is 4. Okay? Now I'm going to keep going with this same pattern. If I have 2 squared and I'm dividing by 2 to the first power, that's the same as 2 to the 2 minus 1 power, which is the same as 2 to the first power, which is 2, which kind of makes sense. If I expanded this all out, this is 2 times 2 times 2 over 2, that gives me 4. And this is 2 times 2 over 2, that gives me 2. So when I go to the next one, if I take 2 to the first power divided by 2 to the first power. Well, we should see that 2 to the first power divided by 2 to the first power should be 1. And let's prove this. So we have 2 to the 1 minus 1. Interestingly enough, 1 minus 1 is 0. So 2 to the 0 power is 1. And if I show this one here, 2 divided by 2 is equal to 1. So the new rule, the extra, this is the only one that you always have to remember, is that anything to the 0 power is equal to 1. Doesn't matter what that is. So I'm going to add this to my rules that I have. So I have, first, if I'm multiplying exponents with the same base, I'm going to add them. If I'm dividing exponents terms with the same base, I'm going to subtract them. If I'm taking a power to a power, I'm going to multiply them. And our last one is that x to the 0 power is equal to 1, and that works for anything. One real quick example that I want to go through that I saw the other day on one of the assignments that a lot of people got wrong was this one right here, where we have 5 to the 3rd power times x to the 4th power times y to the 5th power, all over 5 times x times y squared. You need to be careful. That's why we talked about bases. The only thing being squared on the bottom is the y. If I were to expand this, this is 5 times 5 times 5, and then I'm going to have 4 x's, and I'm going to have 5 y's. Now when I go to expand this, I'm going to group the same bases together. So I'm going to put the 5 underneath that 5, and then I'm going to move this over and put the x underneath this x, and then I'll put the 2 y's underneath this. Well, 5 divided by 5 is 1, x divided by x is 1, y divided by y is 1, y divided by y is 1. So this then becomes 5 squared, because there's 2 of them, times x to the 3rd power, there's 3 being multiplied together, times y to the 3rd power. And if I look at this, well, 3 minus 1 is 2. 4, and if there's nothing here, that's a 1 actually. So 4 minus 1 is 3, and 5 minus 2 is 3. Okay. I hope this helps for your homework today.